Welcome. Today we are going to talk about logarithmic rules. And before that I am going to introduce you what is logarithm. So logarithm is a way that we are defining our powers and indices in terms of it's a different way of representing our powers and indices. And usually when you take logarithms, why we use logarithms? We use logarithms in order to make sums easier. You will be in a real doubt, how do you gonna make sums easy using logarithms? So logarithms, we have defined values in the base of 10. So you might have heard these things. So today we are going to talk about only logarithmic rules, but now I am going to introduce you why we are going to use logarithms. So when we have a base in term, let's say in term of 2, in base of 10, in base of 8, we have defined values for each number. So we're going to use these logarithmic numbers to make the sums easier. Like when you are, just take an example, when you are multiplying two very big decimal numbers, so what it takes time and it is really hard to multiply those two numbers because we are reluctant to deal with decimal numbers and usually in the division also. So using logarithms, we can convert that multiplication into an addition in terms of logarithmic rules. So if I say you can get the answer of a multiplication by using addition, so I think that might make your mind clear that these logarithms can help you to do the sums. So as per our discussion, so today we're going to talk about logarithmic rules. So this is our first logarithmic rule. Before go to logarithmic rules, I'm going to introduce you to some basic things regarding logarithms. Rather than logarithms, you need to know about powers and indices. So this is how you usually write the power and indices with its value. Let's say 2 to the power 3, 8. How does this 8 comes? 2 to the power 3 means you continuously multiply 2 3 times. 2 into 2 is 4, 4 into 2 is 8. So that means you multiply 2 3 times. Just like this, 2 into 2 into 2. So 2 into 2 is 4, 4 into 2 is 8. So you can count these numbers 1, 2, 3. That means 2 to the power 3 is 8. So we usually name this as the base, then this as the index or the power. That's why I always repeated this, 2 to the power 3. So we name this as power or index. This is the value. This is the value. So you need to have this understanding to go for logarithms. So that's why I introduced this one. So I think it cleared. I hope that it cleared your mind. As you know, how to write a power in terms of logarithms. So I will take this one as example. Let's take 4 to the power 3. So what is 4 to the power 3? As I told you, you can count that one. 4 into 4 into 4. So let's count 4 into 4, 16. 16 times 4 is 64. So 4 to the power 3 is 64. So how do you write this one into logarithms? How do you convert this power into a logarithms? That is the first rule, converting a power into the logarithms. So this is how you write that one in logarithms. So first of all, you write log. And here lies the base. So what is the base? This is our base. And here lies the value. What is our value? Here. This is the value we need. This is the value I have introduced already in the first one. So this must be equal to this is equal to power. So power is here. Here you should have power. So when I fill these three gaps, what comes here? here is the base, this is our base, log base 4, and this is our power, this is our value 64, power is 3. So this is how you write a power in terms of log. So log base to the power 3 is 64. Log base, so this is how you repeat that one. Log base 4 to the power 3 is 64. Or else log base 64 in terms of log base 4 is 3. So let's go for some exercises. So I have three sums. I have three sums. 2 to the power 3 is 8. 3 to the power 4 is 81. 10 to the power 3 is 1000. So this is how you're going to write these things in terms of log. So log, our base is 2. Here lies the base. And this is our value. And this one, then log 2 to the power 3 is the answer. So this is how you write indices in terms of logarithms. And here also log, our base is 3 and our value is 81 is equal to 4. Log base 3 to the power 4 is 81. So this is log base 10. Your value is 1000, your power is 3. And when you talk about this one, this log base 10, there's a special indication for this. So I'm going to talk about that in the next one. So we can write log base 10 in a simpler form like this, LG. So here the LOG was here, now the O is missing and the base 10 is missing. So this is the simplest way of this is a simple way of defining log 10 as another way, So we use this because usually we get almost all the logarithmic values, logarithmic tables in terms of in the base of log 10. So writing this log 10 is kind of takes time. So we use this one to simplify, to save our time. So I can write some examples like this. So let's say log base 10 to the power 4. So log base 10,000 is 4, not 4, that is so log base 10,000, the power is 4. You can count it 1, 2, 3, 4. 4 zeros, that means power 4. So we can simplify this one. We can simply write this one like this. LG 10,000 is 4. That's how we write this right there. So another example, log base 10 to power 200 is 2. Usually you know 10 into 10 or else 10 to the power 2 is 100. We can write this like this in simpler form. Log 100 is 2. Rule number 2. So I told you before that what if I tell you that you can do a multiplication as a addition using logarithms. So this is the way, this is the rule that I'm going to define you that how do you do that. So let's take a log sum. So log, we don't, let's ignore the base here. Let's ignore the base here. It doesn't matter. Usually the base must be in the same. So this is our rule 2. So I told you that before. We can do a multiplication as a addition and a division as a subtraction using logarithm. So so here I'm going to show you how do you gonna do that. So let's say log a, the base is a, and I have to multiply, let's say, m into n. So what we can do using logarithms is we can separate these two, log a to the power m and log a to the power n. So what is the most significant point here? Can you see? There is a addition in here. So you can convert a multiplication in terms of a addition using logarithm. So a very simple example, log 10 to the power 100 into 100. So a simple example, log 10 to the power 100 into 1000. So same base. So what we can do is I can separate these two. So like this, log 10 to the power, so log base 10 100 plus log base 10 1000. So what comes here? As you know, log base 10 100. So how do you, so how can you write 100 as a power and indices of 10? So 100 is 2 to the 10 to the power 2. So here the answer is 2 and addition is here. So here the answer is, the 1000 comes 10 to the power 3. So 2 plus 3, the answer is 5. So you can exactly get the log values of this one as a log values of a multiplication as log values of a addition. Here rule number 3. So I'm going to introduce you how to convert a division into a subtraction. So log base a m divide by n. So you can write this as, you want to separate the logs, log base a m. So this division becomes a subtraction when you separate the logs, log base a n. So that's how you convert a division of logarithms into a subtraction of logarithms. Let's take a very simple example. Log base 2 to the power 128 divide by 8. So this is how I'm going to do the sum. So I have to separate the logs. Log 2 to the log base 2, 128. I can subtract this one from log base 2, 8. So what comes here? So how do you get 128 the answer? So this is how we're going to take it. You have to count that one. So 2 times 2. 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32, 32 into 2 is 64, 64 into 2 is 128. That means 2 to the power 7. Here the answer is 7 and you have to subtract that one from the answer coming, the power of this, power of 8 in base 2, that is 2 to the power 3. So 7 minus 3, the answer is 4. So this is how you convert a logarithm, a division. So this is how you convert a division of numbers into subtraction of logarithms. Rule number 4. When you are given a number, a log value like this, log a to the power, so log base a, b to the power c. So you can write this one like this. So this power c is kind of weird when you see this here. So you can take this c up to here. That is the rule of this one. So I can write this one like this, c into log a to the power b. So a simple example, very small one, log 3, log base 3, 3 to the power 4. So if you substitute this one, a as 3, b as 3 and c as 4. So I can write this one like this, log. So if you substitute these powers, so if you substitute these digits, a as 3, b as 3 and c as 4, you can write this one in form of this. So these are we going to write. You can take this 4 to the up front, 4 times log 3 to the log base 3 to the value 3. So you know log base 3 to 3 is 1 because 3 times 3, so 3 to the power 1 is 3. You see there is a dot means a multiplication. You multiply this 1 into 4, the answer is 4. So if I simply prove this one, this is as this, so I'm going to prove this one is correct. So if you take 3 to the power 4, just take it, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So log 3 81, the answer is usually 4. So here also the answer is 4. Here also the answer is 4. So no need to worry about writing this one in terms of this. So rather than that, there is a universal theory. The power of the zeroth power of any base, the zeroth index of any base is 1. So if you take 2 to the power 0 is 1, the zeroth index, the zeroth power of any base is 1. 4 to the power 0, that is 1. If you take 1,100,000 to the power 0, that is also 1. No matter you take it more than 100,000, it doesn't matter. If the power or the index is 0, your value is 1. Then universal theory number 2, if the power is 1, if the power is 1 of any base, the value is equal to its same base. So if you take 2 to the power 1, the value is 2. Thus, if the power is 1, the base lies here also. The value of the base comes here. If you take 3 to the power 1, the value is 3. If you take 100,000 to the power 1, the value is 100,000. So today I hope that you got cleared about the all logarithmic rules which is used for usual mathematics, not for higher maths. There are 2-3 other rules regarding the higher maths. So I just talk about the usual mathematic rules. So drop your comment at the down section of the comments. So let's see how we're going to improve this one. So let's see how I can help you to improve your mathematics knowledge. So let's see how I can help you to improve your mathematics knowledge in simple ways. So subscribe us, be with us, and don't forget to leave a comment. Thank you.